Now, our first question is dinitrogen tetroxide N2O4 decomposes into nitrogen dioxide NO2. Now, the reaction is reversible. As you see, the sign is a reversible reaction. N2O4 gas gives twice of NO2 gas. Now, N2O4 is colorless. This is brown gas. A gas syringe containing a mixture of dinitrogen tetroxide and nitrogen dioxide gases was sealed and heated. After reaching equilibrium, the mixture was a pale brown color. Now, pale brown is because you have brown gas as well as it is with a colorless gas. So that's why it is pale brown. Now, state what is meant by equilibrium. So see, in a reversible reaction, equilibrium is actually a stage in which the forward reaction is equals to the reverse reaction or the backward reaction, or the formation of, or you can say the concentration of reactant and products is same. So what we will write over here is the rate of forward reaction, equals the rate of reverse reaction. Or you can say the backward reaction. That is the same thing. You can write any of the two. And the concentration of products and reactants are also constant. Since this is a reversible reaction, so the rate of formation of product as well as the rate of formation of reactants, that is same. So the concentration is same. B part. The plunger of a gas syringe is pushed in. The temperature does not change. Okay, the mixture initially turns darker brown. After a few seconds, the mixture turns light brown because the equilibrium shifts towards the left. Okay, now explain why the mixture initially turns darker brown. See, when you are plunging that syringe, so see, now that gas, that brown gas is now in a smaller volume. So that's why it turns initially darker brown. So what you will write is that our answer will be, see, since the pressure increases, now the pressure increases, which brings the molecules of NO2 closer. The molecules of NO2, which is brown gas, closer. So that's why it appears initially darker brown. Now, second question is, the next part means, explain why the position of equilibrium shifts towards the left. Now see, you can see on the left hand side the number of moles of gases. The gas is 1, whereas on the right hand side it's 2. So here is 1 mole and on the right hand side it's 2. So when you increase the pressure, the equilibrium will shift towards where the number of moles is less. So what you will write? Number of moles of gas is less on the left side. Left side, yeah. Now, the forward reaction is endothermic. Now see, it's an endothermic. State what happens to the position of equilibrium when the temperature of the mixture is increased. So endothermic reaction means in that reaction you have to supply more heat. Now since this is endothermic and you are giving it more temperature, so what will happen? It shifts towards the right because the forward reaction is what? Endothermic. That's why it shifts towards right. So what you will write? Shift towards right. Now state what happens to the rate of forward reaction and the rate of backward reaction when the temperature of the mixture is increased. Now see, when the temperature of the mixture is increased, it's an endothermic reaction. Means it is already taking in more heat. So what will happen? The rate of forward reaction will increase. Now what will happen to the backward reaction? Now see, when the temperature is increased, So now the molecules are colliding with at a faster rate. So that reaction will also increase. Now this is the interesting part. So what you will write, the rate of forward reaction will be faster. Even the rate of backward reaction, that will also be faster. Like our video, please do like and share. And to score good marks, do subscribe as well as press the notification bell icon to all to watch our latest videos. Thank you. Now coming back to the question. This question is about salts. Salts that are insoluble in water are made by precipitation. Lead second iodide PbI2 is insoluble in water. All nitrates are soluble in water. All sodium salts are soluble in water. You are provided with sodium lead nitrate, lead 2 nitrate, PbNO3 whole twice, and sodium iodide NaI. Describe how would you make a pure sample of lead 2 iodide by precipitation. Your answer should include practical details, a chemical equation for the precipitation reaction. So starting with that, what we will write over here is that, see, first of all, add water to both the salts. So these are the two salts, PbNO3 whole twice and NaI. So you will add water to both salt taken in a different test tube. So what you write, add water to both salts taken in different test tube to make solutions. So now you have two solutions in two different test tube. To make solution. Now add both the solution in a beaker. Now you will take a single beaker, and what you will do, you will add both the solution in a beaker. A solid precipitate forms, which is PbI2. So what you will write here is add both solution in a beaker, and the reaction will occur. You know this reaction is a double displacement reaction. And a solid precipitate, which is actually insoluble, forms PbI2. So add both solution in a beaker. A solid precipitate the reaction will form a solid precipitate, which is PbI2. Lead iodide, actually this is insoluble, so that's why it is solid. Now what you will do, our next step is filter and wash with water. Wash with water is to remove any impurities if it is present. Filter and wash with water and dry the solid to obtain solid PbI2, lead iodide. Filter and wash with water and dry the solid to obtain solid PbI2. To obtain this solid PbI2, which is the precipitate, and it's insoluble. Now we have to write which is lead iodide, lead 2 iodide. Now we have to write the chemical equation. So the chemical equation will be, see, you will write PbNO3 lead nitrate, PbNO3 whole twice actually, plus NaI, sodium iodide. So that gives, this is a double displacement reaction. It forms sodium nitrate NaNO3 plus PbI2. Lead iodide. Now balance it. Balancing it, see, here NO3 is twice. So we write 2, Na2, so here 2. Balancing is complete. Now we have to write the state. See, PbNO3, this is aqueous. This is also aqueous because they are forming a solution. This will also be aqueous. It's soluble, and this will be solid, which is a precipitate. Solid. Okay. Nitrate decompose when heated. Yeah. When hydrated zinc nitrate is heated, oxygen gas is given off. Describe a test for oxygen. See, we know that the test for oxygen is if we bring a lighted splint near the test tube containing oxygen, it relights. So what will be the test? Is glowing splint. You can write glowing splint. And observation, it relights. That will relights. Yeah. Complete the equation for the decomposition of hydrated zinc nitrate. So you can see it's zinc nitrate, and here is the decomposition reaction. So basically we have to balance it. So to balance it, see, it's twice of ZnNO3 whole twice dot 6H2O. Now see, there are 2 zinc. So we write 2 over here. So the zinc is balanced. For the nitrogen, see, there is nitrogen is 2. 2 into 2, 4. So we write 4 over here. Oxygen we don't have to write. And for hydrogen, see, this is 6 into 2, 12. 12 into 2, 24. So 2 is already over here. We will write 12. Now to quickly check for the oxygen, see over the left hand side how many are there. See, this is 6 into 2, 12. And this again 6 into 2, 12. So 24. And so total 24 atoms on the left hand side for oxygen. And if we look at the right hand side, it's 2 here, 8 over here, 10, again 2, 12, 12 plus 12, 24. So on both sides oxygen 24, that is also balanced. Some sulfates are hydrated. Okay. When hydrated sodium sulfate crystals Na2SO4 dot XH2O are heated, they give off water. So here's the reaction. Na2SO4 XH2O gives Na2SO4 solid plus XH2O, which is gas. A student carries out an experiment to determine the value of X in Na2SO4 dot XH2O. Step 1. Hydrated sodium sulfate crystal are weighed. Step 2. Hydrated sodium sulfate crystal are then heated. The remaining solid is weighed. Describe how the student can check that all the water has been given off. So basically, see, he will actually repeat the step 2 and 3. And he will do it 2 to 3 times. Or you can say he will keep on doing that until he get a constant mass. So what will be your answer? That he will heat again. He will heat again and weigh the remaining solid. Heat again and weigh the remaining solid until he gets constant mass. Until he gets constant mass. Yeah. Now, in an experiment, 1.61 gram of Na2SO4 dot XH2O is heated until all the water is given off. The mass of Na2SO4 remaining is 0.71 gram. They have given you the molar mass of Na2SO4 and water. Now, determine the value of X using the following steps. Calculate the numbers of moles of Na2SO4 remaining. So, we know that number of moles is given by the formula is mass upon the molar mass. So what is the mass? 0.71 gram, and molar mass is given 142. So number of moles will be 0.71 divided by 142. So here's the formula, mass upon molar mass. So number of moles will be 0.71 divided by 142. That will be 0.005 mole. Now calculate the mass of H2O given off. So we know that the total mass of the salt is 1.61 and the solid is 0.71. So if you subtract 1.61 minus 0.71, so that will give you the mass of H2O, that is 0.90 grams. So the mass of H2O given off will be 0.90 grams. Calculate the number of moles of H2O given. Applying the same formula, moles is mass upon molar mass. What is the mass? We know is 0.90 and the molar mass of water is 18. So 0.90 divided by 18, that is 0.05. So the answer is 0.05. Now the next question is, determine the value of X. Now see, if you see, look at this equation, Na2SO4 dot XH2O. You see that 1 mole of Na2SO4 is actually having X moles of H2O. So here is 1, here is X. So if we calculate the number of moles, so see, 1 mole of Na2SO4, it is actually combined with X moles of H2O. Now we know that that is 0.05 moles that we have calculated of Na2SO4 was actually attached with 0.05 moles of water. So now 0.005 moles of Na2SO4 that is attached with 0.05 moles of H2O. Now by using the unitary method, we'll calculate the number of moles of, 1 mole of Na2SO4. Using unitary method, so that will be 0.05 divided by 0.005 times 1, which is the same thing actually. So this is actually equals to 10. So this 10 is what? Is the value of X. As you can see, this 1 mole of Na2SO4 is equals to X mole of H2O, which is 10. Next question. This equation is about iron. Okay, iron is extracted from the main ore in a blast furnace. As you can see, the blast furnace. So the raw material, coke, iron ore, limestone are added. Waste gases is given off. Then you have chamber A and B. And the molten iron at the bottom, which is taken out. Now name the main ore of iron used in a blast furnace. We all know that it's hematite. So hematite is the main ore of iron. So we write hematite. Name the substance that enters the blast furnace at A. See, we need air. So actually, air is entered from at the point A because that is used for the combustion. So you can write here air. Name the substance that leaves the blast furnace at B. See, we know that B is basically a slag or calcium silicate which forms above molten iron to prevent it from oxidation. So here you can write slag or calcium silicate. Both are correct. Give 2 reasons for using coke in the blast furnace. We know that coke is basically, it burns out, it is used as a fuel to give out heat. So here is a coke. Coke is actually a refined form of carbon. It burns to give out heat. You can write it is a fuel which burns to give out heat, because in a blast furnace it is obvious that you requires heat. It burns to give heat, and also it reduces, it acts as a reducing agent. It reduces iron oxide to iron. Iron oxide to iron. Next one. Another ore of iron is iron pyrite, FeS2. Iron pyrite contains the positive ion Fe2+. Deduce the formula for the negative ion in FeS2. See, in FeS2, Fe is 2+, so this is 2-. So either you can write S2 2-, or there are 2 molecules of S, which is S-. You can write this also S-. Next one. Iron is a transition element. A list of properties of iron is shown. Iron is a good conductor of electricity. Iron forms soluble salt. Iron forms colored compound. Iron has variable oxidation state. Iron acts as a catalyst. Iron forms a basic oxide. Give 2 properties from the list in which iron differs from group 1 element. So see, iron is basically a transition element. So how does it differ in group 1 elements? So see, first one is it forms colored compound. Since iron is of transition elements, so iron forms colored compounds. And second is iron has a variable oxidation state. So you can write this: iron has variable oxidation state. Oxidation state states. Next one. Give 2 properties from the list in which iron is similar to group 1 element. So two properties we know: iron is a good conductor of electricity. They are group 1 elements also, and also they all form basic oxide. So two that we will write is: iron is a good conductor of electricity. Iron is a good conductor of electricity. And iron forms a basic oxide. Yeah. Steel consists mainly of iron. Iron forms rust when it reacts with water and oxygen. Magnesium blocks can be attached to the bottom of steel boats. The magnesium does not completely cover the steel. Okay, so you can see the steel boats and magnesium blocks. Now the question is, explain how magnesium blocks prevents iron from rusting. We all know that from the reactivity series, magnesium is more reactive than iron. So when it comes to the oxidation, magnesium will be oxidized, thus preventing iron from rusting. So what we will write here is, magnesium is more reactive than iron. Is more reactive than iron. So it is oxidized easily in preference to iron, thus preventing its rusting. So it is oxidized easily in preference to iron. Okay, so that will be the answer. Next one. Explain why replacing the magnesium blocks with copper blocks will not prevent the bottom of the board from rusting. We all know that copper is very less reactive. So when it comes to oxidation, iron will be oxidized first. So what you will write? Copper is less reactive than iron. I think that will be your answer. So what we will write here is, copper is less reactive than iron.